Okay, today we are on our last or final unit of the year. Wow, we made it. This is the last lesson. Bivariate Statistics. That's our week 9. Okay, we made it through, guys. End of the year unit. So before we go there, now what we do is I want to share with you about one proverb, which is an everyday proverb of all time. It says, "Tell me and I forget, teach me and I may remember, involve me and I learn." This is from Benjamin Franklin. Really, guys, when you hear something, if somebody tells you, you might forget it, and if you are taught or if somebody teaches you, you might remember better than hearing or listening to what was said. But when you are involved, you learn more. So involvement is the key. That's why we are giving you every week an assignment. And so in this last one, you will be doing your weekly week 9 assignment, and also you'll be doing the final project. So I hope through involvement, you learn more. Okay, let's go to today's topic, which is bivariate statistics. First of all, bivariate statistics or analysis is a quantitative analysis that involves two variables. So last week, you remember, we worked only with one variable. This week we work on two variables. So this is just to determine the practical relationship between those two variables we study. For example, you might study about height and weight at the same time, these two different variables. So in this case, we call it bivariate. Data is to be studied under bivariate statistics. But if you independently study about height or weight separately, like what we did last week, it's called univariate analysis of a univariate data. So univariate or bivariate depends on how many variables you are studying, actually. So last week, if you remember, only you took a height data and you were finding the mean, median, mode, standard deviation, range, quartiles, interquartile range. And so if you are considering only one of it, it is called univariate analysis or of univariate data. This week we are studying about two variables at a time. Okay. Examples of univariate and bivariate might be, say, in the univariate study, you might study a group of college students to find out their average SAT score, or you might study a group of diabetic patients to find their median weight or the standard deviation of the weights. This is supposed to be just a univariate study. But when you are studying in bivariate statistics, you study about a group of college students' average SAT score versus their age. So you are studying these together. So the question or the puzzle is about what's the relationship between the SAT score and their age. Or you might study how the weights and heights of college students are related, that the weights go with their height. So when you study these two different variables, it's called, bivariate study of the bivariate data. Okay. Some examples and uses of bivariate study would be, you are studying two sets of items that are dependent on each other when you are studying. The data could also have two sets. So, for instance, ice cream sales compared to the temperature of that day. We know as the temperature increases, the ice cream sale will increase, and so we are studying about the relationship between the two, even though we know, but how much is the relationship between the two. Traffic accidents along with the weather on the particular day. Okay, what's the relationship, what's the correlationship between the two? So bivariate data has many practical uses. For instance, you will predict the natural event or the occurrence of some natural event depending on the occurrence of another event. So it has a big or a great use in everyday life, this bivariate study. Okay. Types of bivariate analysis. The first one is scatter plot. When we say scatter plot, it's about it's a graphical display where you see the relationship between two quantitative variables. So it is visual, ideal form of presenting a data where you see a pattern among the data displayed. For instance, or the main thing is a scatter plot consists an x-axis, a y-axis, and a series of dots. Series of dots would be presented in this scatter plot. So we will observe what the data set shows, or how they are scattered, or how they are displayed, how the position of each dot, in fact, shows you in terms of x and y axis where the point or the data's point would be. Okay, let's see this graphically, what scatter plot looks like. Suppose if you have this table shows the height in inches and the weight in pounds of 5 starters of a high school basketball team, say. So the height is given in inches here, 67, 72, 77, 74, and 69 for 5 starters of the basketball team. And then the weights of each is given here. So the scatter plot would be weight versus height. So the height, for each height, you are plotting the weight value. So that is a scatter plot. Okay, so this is one way of studying bivariate data. Reading the scatter plot means a dot on the scatter plot shows you or represents each player. So for instance, the first dot tells you the shortest student with lightest weight, or shortest and lightest player with a height of 67 inch and a weight of 155 pounds. For instance, here, this is the lightest player with the shortest height. It is found here at the bottom. So the tallest and with more or the most weight, the person with the most weight would be shown at the top. So this is how we read it. Anyway, these scatter plots are helpful, especially in understanding the patterns, how the data go, in what pattern they go. If you see it goes from bottom left to top right, so we can see there is a consistent or uniform increase. Anyway, the pattern is just increasing. The pattern increases. So in terms of x and y, we can read the scatter plot. So for example, the above scatter plot shows the relationship between height and weight is linear. It goes in a linear pattern, and it is strong and has a positive slope. As we know, a line which goes from left to right increasingly has a positive slope. Okay, the second way of bivariate study is regression analysis. Regression is the best guess in using a set of data to make some kind of prediction. It's about fitting a set of points to a graph. Regression analysis can give you the equation for that curve or line. So what we are making is given the scatter plot, what curve or what line best fits to those points. It's the study of what the regression analysis or regression study mean. It can give you also a correlation coefficient. Especially linear regression is one of the regression techniques that statisticians use to describe the relationship between a dependent and dependent variables by using a line that best fits. Linear regression uses a line that best fits into those group of data points. So there are different types of regressions because there are different types of curves that fit to a data, but when you are taking a line, it is called linear regression. It might be exponential curve, it might be logarithmic curve, whichever fits to a data you are using. Anyway, we concentrate on the linear regression for this course. The third one is correlation coefficient. This correlation coefficient usually the symbol would be R. It measures the strength of association between two variables, how strong a relationship is between two or among more data values. For this course, we are using the relationship between two quantities, how much it is strong or weak, what relationship, what coefficient will show us how much they are correlated with each other. How do we interpret? Always the absolute value will tell you the direction and the magnitude. The sign will tell you the direction of the pattern, but the absolute value tells you the magnitude of the relationship or the correlation between the two variables. So the value of correlation coefficient or R ranges between -1 and 1 always. That's the value. The greater the absolute value means of the greater the absolute value of the correlation coefficient means the stronger the linear relationship is. So for instance, if you are very closer to 1 or -1, it will indicate a strong relationship between the two than are closer to 0. So closer to 0 is a loose or a lower relationship or very minimal relationship between the two quantities. Closer to 1 would be stronger. Okay, so more about correlation coefficient. The strongest linear relationship is indicated by -1 or 1. Always if R equals 1 or -1, it is the strongest one. The weakest linear relationship is indicated by correlation coefficient equal to 0. So if it is 0, that means there isn't any correlation between the two variables. A positive correlation means that if one variable gets bigger, the other variable tends to get bigger too. Likewise, if one variable gets smaller, the other variable gets smaller. So for example, shoe size go up or down depending on the foot length. So with the longer foot length, we know that the shoe size would be bigger. So such type of study is what we are studying in this process. A negative correlation means that if one variable gets bigger, the other variable tends to get smaller. It is a negative correlation between the two. If one is increasing, the other would be decreasing. This is called negative correlation. For instance, the amount of gas in a tank decreases in almost perfect way when you are traveling more. So there is a perfectly negative correlation between the amount of gas and the distance traveled. Because the more distance you travel, the more gas you are using, so the amount of gas in your tank would be smaller. So this would be a good example of negative correlation. Okay, 0 means that for every increase, there won't be a positive or negative change. The two are they are not related. Okay, so this table gives you if the correlation is between 0 and 0.25, it is usually very weak. If it is between 0.25 and 0.5, it is weak. But if it is 0.5 to 0.75, moderate. 0.75 to 1 is considered to be strong. As you see, as you go closer to 1, strong correlation. When you are closer to 0, it is very weak. Likewise, this is for positive. For negative, you can do it. You can understand the same way. For instance, if the R value is closer to 0, from negative 0.25 up to 0, it is very weak. But from negative 0.5 to negative 0.25, weak. From negative 0.75 to negative 0.5, moderate. Negative 1 to negative 0.5, it would be strong. The closer you are to negative 1 or 1, it is strong. But the closer to 0, it is weak. That's how we go with it. Okay, correlation coefficient R tells you how much variables are related. It gives you quantitative measure of the relationship between quantities. This can show you the scatter plot and correlation coefficient. This is 1, perfectly maximum positive correlation. This is maximum negative correlation. As you see it here, you never see neither increasing or decreasing in consistent manner. So this is here and there. There is no any correlation between two quantities. It is 0. Correlation coefficient is 0 in this case. This shows kind of strong positive relationship closer to 1. This type of scatter plot. This moderate negative 0.43, if you see the trend is in the negative way, so with a negative slope. So this is negative 0.43 is a moderate one. And this one is strong, but instead of being closer to 1 like 0.8 or 1, it is 0.71. This happens because of the outlier. The outlier, we have this point there. Because of that, it would be still strong, but not that much strong like this one, where the values are, or the points are close to each other with the same trend. Okay, so we can differentiate the scatter plots, or we can associate them also with the correlation coefficient, how the points go. Here the remark on absolute value of the correlation coefficient, is that it gives the relationship strength. The larger the number in the absolute value, or the absolute value larger, means there is strong relationship between the quantities. For example, absolute value of negative 75, absolute value of negative 0.75 is 0.75, which has stronger relationship than 0.65 when we are comparing the two correlation coefficient. The 0.65 is smaller than that. But without absolute value, the negative 75 tells you it is a negative, but strong, but still, even though it is negative correlation between them, it is a strongest one, or a strong one. Okay, now I will demonstrate how we find the regression equation. This is the following step using Desmos. Okay, first of all, we are using the line y equals mx plus b. But how we get m and b is the question. For this, we go to Desmos on the graphing page, then click plus on plus at the top left corner, and then we'll select table. Then we will enter our independent variable into the first column x1, and the dependent variable into the second column y1. After we enter all the values, then next in the box below the table, we write y1, this symbol, which is almost to mean approximately a wave type symbol, this one, then m x1 plus b. This symbol is, sometimes they call it tilde. Anyway, it is found on the top left corner above the tab key on the computer keyboard. Okay, after we enter the data values in the table and then writing this, what we get would be the following. The result would be the scatter plot would be plotted for us with the regression line, and also we'll find the values of m, b, and correlation coefficient. So this will give us the way how to write the equation for the regression line. mx plus b, because we can get m and b from that and then substitute here. And also we can talk about what type of correlation we have between the two variables. The R will tell us that. Doing so, we can find different other values such as R squared, which they call it causality coefficient, so we don't need it for this course. And there are also other terms like residual, and so you don't need those. What we need for this course is M, B, and R. Okay, let's demonstrate this in using example. For instance, statistics performance versus math aptitude score. Suppose last year 5 randomly selected students took a math aptitude test before they began their statistics course. So the statistics department has 3 questions here to know if there is a correlation between the aptitude test and the statistics course. The first question they want to ask or answer is, what linear regression equation best predicts statistics performance based on math aptitude score? They want to find the equation of the line that best fits to the points about the 5 students' scores in aptitude math test and statistics. Second, if a student made an 80 on aptitude test, what grade would we expect her to make in statistics? The third question is, how well does the regression equation fit to the data? So these are the 3 questions to be answered through the process of regression analysis, or in this bivariate statistics. Okay, there is an example. I'll show that example and demonstrate on Desmos, but I don't want you to see the result for now. Just the aptitude test scores are given here. These are the aptitude test scores. These are the statistics grade, and then we enter this into Desmos, and then we'll see what correlation we find between them, and also what would be the equation for the line of best fit or regression line. Okay, go to Desmos. When we go to Desmos, we start graphing here, and then left top corner plus sign, we click in that, add item it says, so we select table from there. Then we are entering in the first column the math aptitude test score, 95, 85, 80, 70, and 16. And also the statistics scores, 85, 95, 70, 65, and 70. Okay. Usually it is good to determine our X and Y scales and how they should go. I go here on the graphing setting to the right top corner. So I need to set my X and Y. As you see, the negatives are there, but negative X and Y are not part of our data here. The scores are positive. So let X start from 0 and go up to 100. I fix that there on setting. Let Y also start here from 0 to 100. That's the test scores. Once I do that, I can make the step by 1 or by 5, doesn't matter. Let's say by 5. Let's put the steps on X and Y axis, the unit 5 there, and also 5 for Y. Okay, once we do that, look, already the points started to be plotted for us, the scattered, the corresponding points. For the first one, you can see, or this point corresponds to one of the data points there, where it is 70, 70, and 80. For the first one, you can see it, which is after 50, 55, 60, 65, so 60 and 70. This one is this one, the bottom one, the least one. Anyway, once we have those scatter plot, and then now we need to put y1, and then that wave type symbol, yeah, it's on top of the tab key on our keyboard, and then m x1. Look, the line is being drawn now for us, plus x1 plus b. Yes, the line is there. Already we find r squared. We don't need that. You don't need this residual. The main thing you need is r here. The r value, the m value is there, the b value is there. Okay, so this will be the line of best fit or regression line which passes through the scatter plot. So that's how we are using. For your univariate data, which you will be working for your project, there is another resource which I will be posting for you, how to use this Desmos to enter your data values and find all the mean, median, mode, or standard deviation, quartiles. There is an easy step. I will post that for you when you do your project. Okay, now let's go back to see the result of this. Yeah, here. So after we do all the steps, look, the R is 0.6931, M is 0.643836, B is 26.78. Then our answer for the first one is the equation for us, y equals mx plus b. M is taken from here, and then b is taken from there. Either you round it or leave it as it is, it doesn't matter, but the equation is that. Okay, so the second question was, if a student gets 80 in aptitude test, how much would she get in statistics? Once you get y equals 0.64x plus 26.78, x is the math aptitude test score, y the statistics grade or statistics score. So you substitute this 80 there and you will get 77.98 or just 78. A student who gets 80 in aptitude, we can predict will get in statistics 78. So this about prediction, about based on one variable how to get the other. Anyway, the regression equation best fits the data as you see it, since the regression line passes perfectly in the middle of the points. It represents the trend of these points, and so also the trend, the direction is in the direction of all the points, so it very well fits to the data. Okay, this is how we do it. Let's take more interpretation. The correlation 0.69 shows it's almost 0.7. There is a big relationship between aptitude grade and statistics. That means there is a strong positive correlation between them, closer to strong anyway. We sometimes say, yeah, it is stronger. Moderate they call sometimes when it is below 0.75 anyway. It's closer to 0.75 to 0.7. Anyway, as a math aptitude grade gets bigger, the statistic grade will get also bigger. That's what we can conclude. And also 0.64 is just the slope of the line. That means the statistics grade increases at the rate of 64% in terms of the math aptitude grade. Yeah. So this is what we can say about that using the correlation coefficient 0.69, strong relationship between the two scores. Another example would be this one. This table shows average snowfall of a town, say in the year 2000 to 2013. Here, year is given, and the amount of snow that fell in different years has been given there. So write the regression equation and predict how much snow has fallen in the year 2015. 2015 is not in here. We are going to predict it, how much it would be. Find the correlation coefficient for the given data of elapsing years and the amount of snow. Graph the scatter plot and the regression line. So already what we do is we enter these values into Desmos. Already I entered it to save our time. I'll show that. For instance, this is the data values, years. This is the amount of snow that has fallen through years. And so this is, the trend is decreasing, unlike the test score we have seen earlier. As the years go, the amount of snow is decreasing. And also we can see on the bottom the values of the regression and the kind. Yeah, our regression is negative 0.8378. That's a negative, a strong negative correlation between years elapsing and amount of snow falling. Yeah, so we can write the equation for this based on this. As you may have got that, the answer would be R is negative 0.8378, M is negative, R is negative, by the way. R is always, in this case, R is negative. I forgot to put negative there. And M is also negative, 2.29 there, 467. So when we have the equation y equals negative 2.2923, x or negative 2.29, it doesn't matter, we can put negative 2.2923x there, where x is the year and y is the amount of snow in inches. So the equation can be given with that. So if you want to find in 2015 how much snow has fallen, we can put 2015 there for x, and we get about 5 inches of snow in 2015. You see the amount of snow is decreasing every year. To find the year for a snowfall of 100 inches, there was a question also: in what year was 100 inches of snow? So you replace that 100 for y, and you are solving for x. Subtract from 100 the 4,624 and divide it by negative 2.2923. So the result for this, the result would be therefore a snow of 100 inches was seen in the year 1971. In the year 1971, we have got a snow of 100 inches. This will answer how much or in what year snow 100 inches of snow has fallen. So this is the answer for that question. Question B, the correlation coefficient is negative 0.84 as you have seen it. So the scatter plot and regression lines are given here. And so R negative 0.84 shows that there is a negatively strong relationship between the years and the amount of snow that was that has fallen, yeah, through years. So there is that much negative strong relationship. This means as the years increase, the amount of snowfall decreases. So really this result agrees with the assumption that through global warming, there is a reduction of the average snowfall. So this goes hand in hand with the assumption we had at this time, even in the current condition. Okay. Okay, so anyway, that's how we find regression line and equation using Desmos, and how we study about relationship between two quantities. This ends the unit and also the year's lesson. But guys, you remember that you have to do your last assignment of the year, which is week 9 assignment on the bivariate statistics. Also, don't forget to do your final project with your partner. You will be given a separate instruction or guidance on that for the final project on univariate statistics, which is on one variable data. Okay, that's what we have for the year and for this week.